Hey, what's up? Welcome back. In this episode, you'll see how to solve day 12, or at least we'll struggle together through day 12 of the Advent of Code for 2023. This one's called Hot Springs, and it's a doozy. It is one of those ones that requires quite a bit of dynamic programming. And yeah, once we get to part two, it gets pretty messy. So let's jump right into it. The idea is that we get a bunch of records, and each row represents a record where we're keeping track of which sort of hot springs are damaged versus operational. So the damaged ones are all of the pound signs, the operational ones are all of the dots. But in some of our records, we have this question mark, which could be operational or it might not be operational. And then on the far right, we have a checksum type thingy, which tells us the groups of numbers that are damaged. In this case, we see there are one damaged, one damaged, and three damaged. So we should expect to see a pound sign, and then three pound signs. And each group of damaged hot springs need to be separated by an operational hot spring based on this checksum. The checksum in this case, 1316, would be something like this one is damaged, these three are damaged, this one is damaged, and then these six are damaged. So part one is we've got to figure out how do we want to iterate through and decode the number of ways that we could achieve this same checksum with these variables. So like where the question mark is the variable, we want to either put a dot there or a pound sign there and have it be valid based on this checksum. And so we need to know like how many different arrangements of operational and broken springs will work with our list here on the right. The way that I solved this at first was to create all the combinations and permutations of pounds and dots that would fit into 3 spaces and then 4 spaces and then, or just to replace all of the question marks. So explode out all the different options and then filter down the ones that are valid. But that doesn't scale, definitely doesn't scale to part 2. And so in part 2, I had to rewrite the entire thing. And so we're going to go through that direction first. So let's open up main.rb. And one of the other things that I found was when you're working on a project like this that is just sort of like whack-a-mole, meaning like every time you make a change to your code, there's a chance that it's breaking some other code somewhere else. I call that whack-a-mole code because you like whack down one of them and another one pops up somewhere else. What I like to do in that case is write some tests. Let's pop in require rspec auto run. There is a tool within rspec that lets you put in this command at the top, and now we can just describe, I don't know, count. It works on basic cases. We don't need to have the best, prettiest test suite here. We just need to have some that we can work with. I'm thinking maybe we should have our test cases be the input here. And then for each one, we can say cases is some list of cases here. And then for these, we can make these what we're going to pass into some parser thing that ends up giving us back what we need to pass down ultimately to count so that we don't have to do too much wrangling. But we will also need to have some expectation piece here. So for each case, let's pass in some number. And okay, so like for part 1 here, this will tell us in the example that there is one possible arrangement for the first row. And that possible arrangement is we have a pound sign, a dot, a pound sign, and then 3 pound signs. And so here we have one arrangement, 4, 1, 1, 4, 10. So 1, 4, 1, 1, 4, 10. And then what we want to do is say cases.each do input. And we want to say something like expect that count, or maybe we want to like parse input into a record to equal the expected. So this parsed input will then be passed maybe to our count method. And maybe our count method is going to take in the string and then all of these different sizes of the groups. and we expect it to come back and give us what we want. So the way that we can run this is just say ruby main.rb. And because we now have this rspec auto run, we will see the output here. So now we're seeing undefined method parse. So let's add a parse method. Parse input, and we could even write parses as expected. And we want it to parse this thing. Expect parse of that to equal, we want this to be an array of numbers. I think that might actually just be it. No, we want it to be, yeah, we want it to give us back this tuple. So let's see. Okay, parse failed. We expected this and we got back that. Okay, so we want to take the line, that's like our argument, and we want to split on space. And then on the left side, we're going to have some record and then group or like sizes. And then we'll say sizes is sizes.split.map2i, and we'll return record and sizes. Let's see if this works. Okay, so we have a passing test for the parse. Now undefined method count. Okay, let's make a count method. And this is going to take in the record and the sizes. Now what we need to do is figure out a strategy for breaking down into subproblems. Okay, so anytime we encounter a question mark, that is going to be a fork where we will have to count what are the possible answers that had a dot versus what are the possible answers that had a pound sign. So that is going to be one of our forks. If we encounter a pound sign, we need to like count up the groups and figure out, okay, if we just saw a dot, then this is the first pound sign. And if we see 3 pound signs and we knew that the number was 3, then we're good. If we see more than 3 pound signs, then it's like an invalid combination. And so then we need to bail. So in this case, if we replace this question mark with a dot, then it's still valid. If we replace it with a pound sign, it's all still valid. So then we need to go to the next step. And on the next step, we need to check like, okay, if we had a pound sign there and the question mark is a dot, is it valid? Yes, because this was a 1. Is it valid if it's a pound sign instead of a dot? No, because this is a 1, not a 2. So we're going to have a bunch of these different cases that are based on the record and like characters of the record. And we're also going to need to keep track of like where we are while we're gathering up the group. So the first step that I want to do is take the record and break up the characters into maybe the current character and then the rest. So this is going to give us the current first character that we're looking at and the rest of all the characters as an array. And what we need to do is say a bunch. We have a bunch of different cases that we need to cover, right? The case when current is in question mark, we're going to have something. If it's a dot, we're going to do something. If it's a pound sign, we're going to do something else. End. Okay. So if it's a question mark, we want to recursively call count with both. So now we're going to call count, and we want to call count with both the period and the pound sign instead of the question mark. Okay, so we need to call count. And for our record, what we're going to do is we're going to use the rest of the characters dot join. That's going to give us like the tail. And then at the head, what we want to do is pound sign plus the rest. Okay, and we're going to still pass our sizes forward. And we want to take the result of that and we want to add that to what if we added the dot onto it also. So in both cases, we're returning the rest of the string. So as soon as we encounter this question mark, we're going to recursively call count on the rest of this substring. So like we're just swapping out this question mark for a pound sign or a dot and then recursively calling. Okay, so that's one of the cases. Now, if it's a dot, then we need to know whether or not we are in a group or not. Let's do the pound sign next as the next state. So if we are on a pound sign, then we also need to recursively call. So we're going to return count, but this time we can just say rest.join and sizes. So if we encounter a pound sign, that means we're like inside of a group and we need to keep going. If we're at a dot, we want to return. Okay, so there's a couple of cases here. So if we encounter a dot, either we're at like the end of a group, right? So we're either at the end of a group or maybe we're at the end of the entire list. So maybe at the end of a group, maybe at the end of a record. One thing that's missing is how we are checking against the sizes. So sizes here will start out as an array like 113, okay? But as we recursively call on smaller and smaller strings and substrings, if we encounter a valid hashtag or pound sign that is a single pound sign followed by a dot, then we can remove the first size from this list. And the goal is to like empty out this list with valid elements. So in addition to sizes, I'm going to pass down the like current group or like group size, and it'll start out at 0. So if we encounter a question mark, the group size will be the same. And yeah, that'll be the same for dot too. So if we encounter a pound sign, then the group size is going to increase by 1 because we just checked off a group size. Now, we don't want to remove from the list of sizes until we get to a period, right? Because the period represents the end of a group of pound signs. So we have a pound sign here, and we have maybe, let's say like these 4 were pound signs, and then we have a dot that ends that group of 4. And so then we're going to call count on this substring that has 1 pound sign and an array of 1, 1 for our sizes. So we know that we're done with this group when we encounter the period that's right after this pound sign. And similarly, we know we're done with this group when we encounter this period after this pound sign. And if the group size, when we're finishing the group, matches the size that's at the head of the list of sizes, then we know it's valid and we can continue on. If it's different, then we need to return 0 because that means we have an invalid sort of size here. So what we want to do is say if group size is greater than 0, which means we're inside of a group, right? Because this group size that's being passed forward is increasing as we encounter pound signs. So if we're inside of a group, okay, so if we're at the end of a group, then what we want to return forward is 0, ideally, but it's possible. Yeah, so hold on a second. So if we're at the end of the group, if the group size is the same as sizes.first, then we can go forward because that means that we're still in a valid state. And we can go forward with sizes from 1 to the end, right? This is the rest of the sizes because if the group size that we just closed off matches the size that's at the front of the list, then we only need to pass forward the rest of the sizes. And we're only going to pass forward like the remaining part of the list. And we're resetting the group size back to 0 so that if we encounter another period and group size is 0, then we're like fine to keep going. Okay, if group size was not the same as the first, then we need to return 0 because this means that we have an invalid case where either the group size was like the group of pounds was smaller than the number or it was bigger than the number. And so if we don't hit it right on the head, we want to return 0, which is like our terminal case to get out of this thing. Okay, maybe we're at the end of a record. So if the group size is not 0, then what we want to do, I think, is return count of, yeah, we want to just keep going. Because if we encounter dots, we should just keep going down the list. All right, let's see if any of our tests are passing here. Let's comment out a bunch. We'll start with one test. And in fact, what might be even better is let's start with literally just a single pound sign and a 1. Or we expect that this is going to give us the count of, there should be one valid instance of this in here. So let's run our tests. Okay, we got a failure. No matching pattern for nil. So that means that record was empty. So if we get to a state where, so we also need like another base case here for returning from this. So if the record is the empty string, what does that mean? Yeah, so if we get to an empty string and sizes is empty, then we want to return 1. Otherwise, we want to return 0. We might need some more base cases there, but we'll start there. Okay, so we expected 1 and we got 0. Another thing that can be helpful when doing this sort of debugging is to put a lambda as the last argument to our spec that will print out input and expected, just so that we can see, or just input, so that we know which example we're looking at. Okay, pound 1. All right, that didn't do what we wanted. So let's do this. Let's print out record sizes and group size up here and run this again. Okay. Oh, okay. So another thing that can be helpful, because we're using the period to know like when we're at the end of a group. What I did was, while parsing, I'm going to append a period to all records. That way, yeah, we'll say record equals process record or something. I don't know. Let's just do dot or record dot at the end, just so that every single record will have a dot. Okay, expected. Okay, so now our parse method doesn't get what it's expecting, so this should get a dot. Okay, now we have 2 passing tests, so that's fantastic. Let's level this up one more. It should work with a dot before it and dot after it. Those should all work. Okay. And then we would expect there to be 0 examples if we put a 2 here, but there's only 1 pound sign and only one way to make a pound sign. Okay, there's 0 examples in that case. Let's see if it'll work against one of these example rows. Oh my gosh, it's working. It's working. Still working. Okay. Wow. I'm surprised that worked. Okay. All right. We might need to come back and handle this, or maybe this is handled by our base cases. Well, let's throw some example input at this. So let's parse our input into these lines. So we'll say data is input.each line. And now we'll say data.each do line. And we want to, yeah, that seems good. Let's do that. Okay, we need to remove some printing. Too loud. Okay, 1 4 1 1 4 10. Holy moly. Okay, so that's like working. So we actually want to add this up. So we'll inject 0, and then this is going to make us have a sum and a line, and we'll add sum plus count. That'll give us some result. We'll say puts part 1 is the result. All right, part 1 is 21, and that matches the example number for the total arrangements in the part 1 example. So our puzzle answer was 8180. So let's grab our puzzle input here and go to the end. And then instead of reading from input.each line, we want data to be data.readlines. All right, 8180. 8180 is... All right, that was our puzzle answer for part 1. Awesome. Okay, amazing. That was fun. Okay. All right, so let's take a look at part 2. As you look at the field of springs, It turns out the records were folded up. Folded up? What are you doing folding your records up? The result is that we actually have 5 copies of itself. So the way that we're going to expand this and make this problem way, way harder is that we're going to take the first part of the line here and make 5 copies of that joined by a question mark. And we're going to take the second part of the line and make 5 copies of that just straight up. So we end up with this for the first line of the first one. So the first thing we want to do is make some new method for part 2 that will expand the lines. So let's make a new test here, and we'll just say it expands as expected. I don't know if I even need to put as expected. I'm being so lazy with the name of my methods here that it's all good. It's all good. For expand, let's expect that expand of parse of this, of like our first line. Is that our first line? Yeah, we want that to equal, actually we want it to expand. What does parse do again? Okay, let's actually have parse return. Yeah, we'll just have parse do the expansion, and we'll just know that that's commented out. Okay, so then we want this to return this giant thing and have a period at the end. And then it should be 113. Actually, yeah, we can just grab this here. Let's see if we run our tests. All right, so we expected this giant thing, but we got that. So inside of our parse method, let's add a new thing here called expand that will take in the record. And it's going to create an array with record in it and then multiply that. Let's actually, let me show you. So in Ruby, if you have an array of elements, 1, 2, whatever, you can multiply that. You can multiply that by some number, and that will give you a new array with those elements repeated that number of times. This becomes really handy when we want to do something like take the existing record and multiply it by 5. And then we can take all of that and join it. And now we can say here, expand our record. Same thing with sizes. We can actually just do sizes times, let's do it up here, times 5. Okay. And if we run our test now, why is it failing now? Okay. So this, why didn't it become this? Yeah, did we do 4 or something? Let's see. Record dot times 5. Oh, dot join on question mark. Yeah, that's right. I forgot. So each of these little segments has a question mark between it. Okay, so now we are passing the parse test. The basic cases is no longer working for some reason here. Why isn't that working? Because now our parse input doesn't do the same thing as it used to. Let's actually make this parse 2. And parse 2 will do the same thing as parse, except it'll do the expansion. Okay, this, yeah, we didn't make this very flexible, but that's okay. All right. Down here, our test should now still work. Maybe. Oh, parse and parse 2. Okay. All right, so we should have kept the other tests with parse, but again, whatever. We're just using the tests to help guide us enough that we don't run into whack-a-mole problems, right? All right, so now if we were to take each of those lines and run parse 2 against the line and then try to run count, let's see what happens here. We're hanging. We are hanging. All right, when I was debugging, one thing that I wanted to see, and this is on the example input, is data, let's put record count is going to be data.count. So we want to know how many records we're processing. And then also if we keep some like counter here, this is just like purely for debugging, just to kind of like get some measurements about how fast our code is running. So we're going to say if the counter mod 100 or even mod 5 puts counter or something, and then we'll do counter plus equals 1. This is literally just for debugging, right? Like we just want to see why it's going so slowly. So 0, 1, 2, 3, 4, 5. Once we get to this like 6th line in the list of records, it's just hanging here. Okay, it finally finished. It took 15 seconds. 525152. 525152 is the right answer for the example group. But yeah, like that's, I don't know, it's slow, right? If we run it, I don't know, let's just run it against our data and see what happens. And I'm also going to comment out the describe block just so that we can see what we're working with. And this is for part 2. So we have, yeah, okay. So let's run this again. Okay, so there are 1,000 records and we've gone through 3 of them. Also, if counter mod equals 5 should be equals 0, and that'll like only print out every 5th one, but we would still be waiting for the 5th one to print out because it's slow. It's not great. Let's trim the fat. So where can we improve? One of the ways to just look and see kind of how this is shaping up is to print out all of the recursive calls to count here and take a look at what the shape of the data looks like as it's coming in. All right, so I'm just going to run it for a few seconds and then kill it so that I can take a look. So in this case, we have 1, 2, 5, 1, 2, 5, 1, and it's exploding out. What's interesting is in this case, the first argument with the string only has 4 characters, but we're expecting to see a group of 5 hashtags, 1 hashtag, 2 hashtags, 5 hashtags, 1 hashtag. So the number of pound signs that are in this list and the number of expected ones total is like way bigger. And even this is like the group, the passing forward group, right? So like 10 represents the size of the number of pound signs we've seen so far. So we want to take, maybe figure out the number of elements here, and if the number of elements, or if any of the sizes here minus, or yeah, if the group size minus any of the sizes here is greater than the number of pound signs, really, then we know we're in an invalid case. We need to break out. So that's one optimization we can try to make. So if sizes.any, where the size, or where the group size minus the size is greater than, no, if it's less than record.length, then return 0. So I think, I don't know, this might help us optimize, but we don't want to break anything. So we want to make sure that we're still running our tests. So let's put our tests back in here and we will run those. And now we're failing because of a base case. Works for our base case. Yeah, let's see. So is this right? So if the group size is, yeah, no, actually it's size minus the group size. If that's greater than record.length, then we need to break up, right? Okay, so that finished successfully. And so let's see if or how much that may have trimmed on our list here. So it's still chunking along. Now we can comment this back out and look at our counter to see if it's counting fast enough to be stomachable. Okay. 0, hanging, Bueller. All right, let's scroll up and take a look while we're waiting for that to like maybe get to the second section there. What else can we trim out here? Okay, let's see. All right, we still didn't finish. So let's run it again with printing out the top level so that we get some more data to play with in our head. All right. So in this case, when I look at this and I see a bunch of numbers here on the right for sizes, one of the optimizations I think we can make is anywhere we see 2 dots, we should collapse those into 1 dot. In fact, like in the input, we are likely receiving stuff that has 2 dots in it that could be replaced with 1 dot, right? Perhaps maybe the input isn't that evil. Let's take a look at the input here. 2 dots, 3 dots. Yeah, anywhere that there's multiple dots, those can be collapsed down into 1 single dot. So let's improve our record parsing here, and we'll say record is equal to record dot. Actually, we can do that after we append this. So we want to G sub any multiple dots with a single dot. And that's going to help a tiny bit. Okay. Still cranking. And look at that. This is such a massive thing that we need to go through. All right. So the next step is, once we've done that, I can tell you from experience that this is not going to be fast enough like this. And one of the major ways we can make it faster is by caching. So like memoizing the results and returning those so that we have a fast return. So the way that this works is we will build a dictionary and we're going to call it cache, and its default will be this empty dictionary. And we're going to use the arguments to count to build a composite key into the cache, and the value in the cache will be the value that we've returned or calculated. So in this case, we can say something like if cache at key, then return cache at key, right? This is like us early returning if we've got a cache hit. Now, what is this key? For now, we can just make the key the list of arguments that was passed in. And now everywhere that we're doing a return inside of count, we want to do cache key is equal to, and I'm going to make this multi-line if. There are other like fancy ways that you can memoize methods in Ruby, but this should work just fine for our cases. Cache at key is equal to this. Cache at key. And finally, cache at key. All right, so let's run it against our test again. Now, yeah, technically we should pass in, we've got a default argument, so whatever it should be. Okay, we're still trying to print something out here that doesn't exist. All right, we still have a passing test. That's great. Let's run it against the test input again, just to see that we're finishing and that it matches the numbers we see over there. Okay, that's going to take a while. Let's comment, or let's like take out the printing of our key. Okay. Okay, that took 24 seconds to compute this. That, my friends, is too long. Okay, let's pass in a specific cache here. So we'll say count 0 cache, right? Because 0 is the number that we're passing forward for the groups. And let's run it again. Okay, 24 seconds. Still too slow. All right, let's get smarter about this stuff. So if our sizes are empty, so if we receive an empty list of sizes here, and if our record does not include any pound signs, then this is a valid exit. Otherwise, if sizes are empty and we do have a pound sign, then that's not valid. Because if we have a size, then we're expecting there to be at least 1. Oh my goodness. Okay, so the cache only works if you actually recursively pass that down here. Okay, right? Many of you are sitting at home thinking, oh my gosh, he hasn't passed the cache down. It's not actually doing anything. Let's see if that, oh my gosh, less than a second, 0.07 seconds. That's wicked fast. Okay, so now we're caching and all right, here we go. Let's see how fast we can get our own actual results. Holy moly, now we're cooking, right? Now we're ripping. Even though this isn't less than a second, this is still not bad. We can like visibly see that we're chewing through the numbers. We know that we expect to go up to 1,000 and we can get like a rough idea for how long that's going to take. And we know we're not going to sit here forever and ever and ever. So let's grab that number and cross your fingers. Holy moly. Okay, that was the answer for part 2. Jeepers. All right, that was a toughie, right? I thought so. I thought so. Maybe it wasn't for you, but it was for me. One of the things that I thought would be cool is to keep using this pattern matching, but make it even smarter about the group size. Because as I was looking at this, I noticed that we could put in group size here, and then it doesn't matter for this case, and it doesn't matter for this case. But for this case, if we have a group size of 1 up to infinity, that is this whole block. And then we have another in statement for if it's a period, then we have that whole block. Isn't that cool? That's cool. All right, so then if we let's just run it against the example here. So it goes fast. Okay. Nice. Okay. 525152. That was pretty fast. Okay. And then what else can we do here? Yeah, I guess like technically we're doing a lot of concatenating and trimming and cutting and whatever, but that is sort of the nature of the beast when it comes to these dynamic programming problems. It's tricky. And yeah, I wonder if any of these actually help. Like, how is that actually helping us speed up? Oh, that one seems really, really important. If I comment this one out, how about that? Oh yeah, that one seems important too. Okay, yeah, if we notice that if we take out our cache, now we're going super slow again because we're not actually having any cache hits that are preventing the recursion. So we really need that one in there. So that's super important. And I guess this is going to be the solution that we land on. There's probably another way to put in, oh, you know what? For a group size, we can probably do something like sizes. Oh, yeah. Let's do that. So let's see. Okay, so if we have a period and the group size is sizes.first, then we return this. Otherwise, it should fall down into this case. I think maybe that'll work. Let's see. Apparently not. Does this need to be pinned? Can we pin it? No? Am I missing? It's expecting a closing. All right, let's just pull off sizes. S is sizes.first. And then if we put S here, does that work? No. What does the pin thing do? Is this? Yeah, okay, so we needed to pin it. All right, so that's pretty neat. I thought I might be able, yeah, I'm not sure. Maybe this only works. Does this work with this notation? No, apparently. Okay. So it does have to be, yeah, that special pin syntax to back to a variable. But now with this, yeah, I really like this. This is cool. So now we've got, yeah, we're using pattern matching all the way down. So this is pretty cool. Thank you so much for watching. Really appreciate your time and attention. Hopefully this was useful, and we'll see you in the next one. Cheers.